Runge-Kutta method. yi plus 1, the next point is yi, previous point, plus h over 6, where h is the step size, ti minus 1 minus ti, and sum of these 4 points, where this k1 is just evaluate the function, k2 is this, k3, k4. So let's use this fourth order Runge-Kutta method to perform one step, okay, with the step size of 0.1. So we have an initial value problem. So this is dy over dt equals some function in terms of dy. So this is f dy, and y at 0 equals 1. So very first point t naught, y naught. So what is happening here? We have a differential equation. At 0, this is t, and our goal is to determine corresponding y values. At 0, y value is 1, somewhere here. Now, we want to just evaluate these y values, that's the solution at different t values, but by hand, we just want to do one step. Using a computer program like MATLAB, we can do many steps. So from here to here, that's the step size of 0.1. So we would like to determine y value at 0.1. So basically the question is asking, what is this? Y at 0 is 1, that's given. That's t naught, y naught. Based on this one, we want to find the y value somewhere. Okay, what is the y value? Okay, that's the question. And this is the function dy. So this one, the fourth order Runge-Kutta method, is a big improvement over Euler's method in approximating the solution. Though it's tedious by hand, but with program such as MATLAB, it is more efficient. Okay, so we're going to take this is true for I equals 0, 1, 2, 3, etc. But we are doing only one step. So let's take I equals 0. Okay, then we get, let me put here, I equals 0 means we get y1, the next point. That's what we want to determine. Y1 is h over 6. Okay, these are same, k1 to k2 plus 2k3 plus k4. Okay, this will be the case. I forgot this one. Y naught plus, because we are taking I equals 0. So let me do that. So the next point is previous point plus this one. And most of the work goes on finding k1, k2, k3, k4. These are given here, and we are taking I equals 0 because we are doing only one step. If we had to do one more, then we would have t1, y1. Then we would just plug in this point, t1, and whatever we find. Okay, so where k1, let's find k1. K1 is given f of t I y I, and we are taking I equals 0. So just evaluate the function at t naught, y naught. Evaluate the function at t naught is the very first point, 0, 1. And here is the function, y prime equals this, which is slope, by the way, t square plus y. So ty, plug in here, so that is 0 square 1. This is ty, t square plus y, which is 1. So that's k1. In the same way, k2 is given in this way, f of ti, but we are taking I equals 0. So t0 plus h over 2 comma y0 plus h k1 over 2 and k1 is found just right here. So this is evaluate the function at t naught is 0. So 0 plus h is 0.1, step size 0.1 divided by 2, that is 0.05, and 0 plus 0.05 is just 0.05. Now here y naught is 1 plus h is 0.1 times k1 is 1 half. So 0.1 divided by 2 is 0.05 plus 1. So 1.05. Okay, so that is f ty. Now here is the function ty, plug in here. Okay, this is kind of easy. T squared, so this is squared, plus y is 1.05. Okay, so plug in here, and I'm just giving you the number using calculator. 1.0525 f ty, t squared plus y. In the same way, we can find k3 here, f of t naught plus h over 2, y naught plus h, k2 over 2, f of t naught is 0 plus 0.1 over 2, 0.05. Here y naught is 1 plus h k1 over 2. Okay, this is k1. Okay, so just do in your calculator. H is 0.1 times 1.0525 divided by 2 plus y naught is 1. Then it comes out to be, so I'm just doing in my calculator, 1.052625. Now this is f of ty, plug in here, t squared plus y. So this is squared plus this one, we get 1.055. Now we'd like to find k4. Okay, here is k4, f of ti plus h, yi plus h, k3. So that will be, we are taking I equals 0. So f of t naught plus h, y naught plus h, k3. Okay, and t naught is 0, h is 0.1. So it comes out to be 0.1. Y naught is 1 plus h is 0.1 times k3 is just found here. And use your calculator. 1 plus 0.1 times this one, it will be 1.1055. Okay, now this is f of ty. Now t squared, 0 squared plus y, it will be simply 1.1155. Okay, now we have all the ingredients. We plug in here. So y1 is then y naught, that's the previous point given, 1 plus h over 6, 0.1 over 6, k1 plus 2k2, 2 times 1.0525 plus 2 times 1.055 plus k4, 1.1155. Okay, just use your calculator, add these times 0.1 divided by 6, then plus 1. Okay, that is 1.1055. Okay, so that is what the value at 0.1. So we found one step, means based on t naught 0, y naught 1, we use step size h 0.1 we found here. So this is, if you want to see what is happening, so we found the y value at 0.1. We approximated to be 1.1055. Okay, it's 3 years, but by hand we can still do one step. So 1.1055. and more digits.